Have you ever wondered how birds navigate across vast distances with such precision? I bet you've never thought about birds as quantum physicists, but today, we're going to explore that mind-bending possibility. You see, birds have this extraordinary ability to sense Earth's magnetic field, a phenomenon we call magnetoreception. But here's the fascinating part. The Earth's magnetic field is incredibly weak, about 50 microteslas. That's so faint that it shouldn't be detectable by normal biological means. So, how do birds do it? Well, that's where quantum mechanics comes into play. Let's start by exploring the incredible feat of bird navigation. Every year, millions of birds embark on epic journeys, crossing continents and oceans with pinpoint accuracy. Take the Arctic Tern, for example. This tiny bird flies from the Arctic to the Antarctic and back every year, covering a distance of about 70,000 kilometers. That's like flying around the Earth 2 times. But how do they do it? Birds use a variety of methods, including the sun, stars, and visual landmarks. But here's where it gets really interesting. They also seem to have an internal compass that allows them to sense Earth's magnetic field. This ability is called magnetoreception. Now you might be thinking, okay, they can sense magnetic fields. What's the big deal? Well, the big deal is that Earth's magnetic field is incredibly weak, about 100 times weaker than a refrigerator magnet. Now, let's explore the quantum explanation for bird navigation. At the heart of this theory is something called the radical pair mechanism. In the eyes of many birds, there are special proteins called cryptochromes. These proteins are sensitive to blue light, and when they absorb this light, they form what we call radical pairs, molecules with unpaired electrons in a state of quantum entanglement. Earth's magnetic field can influence the state of these entangled electrons, potentially creating a signal that the bird's brain can interpret as directional information. It's as if the birds can see the magnetic field as patterns in their vision. Sounds incredible, doesn't it? But there's growing evidence to support this theory. For example, birds lose their magnetic sense when deprived of blue light, which aligns with the role of cryptochromes. Also, weak oscillating magnetic fields can disrupt birds' navigation, consistent with how radical pair reactions would behave. If this quantum compass hypothesis is confirmed, it would be revolutionary. As we wrap up our quantum journey through bird navigation, I hope you're as amazed as I am by the potential interplay between quantum mechanics and biology. We've explored how birds might be using quantum entanglement to navigate, turning their eyes into living quantum compasses. So the next time you watch birds soaring through the sky or migrating in perfect formation, remember that you might be witnessing quantum mechanics in action. Nature continues to surprise and inspire us, reminding us that there's always more to discover about our amazing world.